Bismillahirrahmanirrahim. Assalamualaikum. My name is Danial bin Muhammad Alwi. Before I begin my presentation, let me introducing our team member. So the first team member is Aminuddin Afiq bin Tamin, and the second our team member is Khairunaquib bin Abidin, and the third one is Danial bin Muhammad Alwi, which is me myself, and the fourth person is Amir Ashraf bin Zakaria. So our team has choose an automation BGP configuration using a Python for this network automation project. So me, Danial, we begins this presentation with the introduction. So let me explain a bit about the background study for this project. So the first point for the background study is we know the internet is a global and decentralized network, which we know it consists of many smaller interconnect network, which the network itself are largely composed to an end system that are referred to a host, and also an intermediate system which are referred to a router. So the next one is information travels through a network on one of the many paths selected through a routing process, which we know the internet routing is based on a two-layer routing mechanism, which are intra-domain routing, inter-domain routing, which is for the intra-domain routing, it is known as internal gateway protocol, and for the second one, which is inter-domain routing, which are known as a border gateway protocol, BGP, is the second routing mechanism. So in this project, we will focus on the second routing mechanism, which is border gateway protocol, which is an important component on internet routing, which is responsible for exchanging information on how autonomous system AS can reach each other. So let's move on to the problem statement. So for the first problem statement, which are the problem itself are related to the BGP itself. So the first problem statement is the manual configuration of specific attributes of BGP appears on dozens of routers, which according to Stewart in 2009, which he says that misconfiguration BGP may result in suboptimal routing, which it can turn increasing the latency and slow the performance of the routing process itself. And the second one is manually configure the specific attributes of BGP leads to misconfiguration, which according to Stewart also, he says that because of the dozens of router, a simple of misconfiguration of BGP itself, such as artificial advertising a short AS path on all internet router, can cause a massive internet outage. Therefore, to resolve it, we came up with this objective. So the first objective is to develop an automation BGP configuration using a Python, and the second one is we want to test and evaluate the automation BGP configuration. And for the scope and limitation for this project, so I will talk about the scope first. So for the first scope for this project is we implement this project by using a Python itself, and the second one is we use a network library which to make a connection with a network device such as a router via a SSH. So the third one is for the testbed, we are using a GNS3 and also a Ubuntu server VirtualBox as a host for the router. And move on to the limitation, we only focus on automations of BGP configuration itself only, and also we only use one type of router, which is Cisco iOS. So that's all for my presentation. I will pass the next topic to Wan Amir Ashraf bin Wan Zakaria. So thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Ashraf bin Zakaria, and in this presentation, I'll be taking over in literature review. Okay, in this literature review, I'll be talking about these four topics, which are network automation, BGP, which is a border gateway protocol, NetMiko, and network device. Okay, what is actually network automation? Network automation is a process of automating configuration, management, testing, implementation, and operation of physical and virtual devices within a network. According to Mihaila, automation of a network is a solution for OPEX, which can be saving operating costs, not only reducing the time spent in configuring the network devices, but also the effectiveness of network maintenance. Procedures that are simpler to execute and enforce on a broad scale are used. Okay, next, moving on to Border Gateway Protocol. Border Gateway Protocol is an exterior gateway classless path vector routing protocol. This routing protocol is used to exchange routing data or information among different autonomous systems. Most internet service providers use BGP to transfer information or data about their different networks. The exchange routes are done over TCP on a port 179, and BGP is a protocol for distance vector routing which uses addressing uh, prefixes as a routing unit. It is also a peer from the network manually configured. Uh, a peer is forwarded to the neighbor to know the path or routes. Then they relate to other neighbors. The IP prefix and autonomous system route are included in the route announcement. Okay, next is NetMiko. Okay, according to Pablo Lucida, NetMiko is a multi-vendor SSH Python library that makes it a breeze connect to network devices via SSH. It is also a library that adds Paramiko, a de facto SSH library in Python. NetMiko simplifies the link SSH to a network device and acts on a device, which also allows you to use simple methods such as send command to execute the commands on a device and to parse the response properly according to the connected devices. Okay, moving on to a network device. In this project, the network device we'll be focusing is Cisco iOS. Cisco iOS, which stands for Internet Network Operating System, is the heart of any Cisco router. The Cisco iOS provides instruction sets necessary in every setting to effectively install, manage, and operate a Cisco router. The Cisco iOS is a versatile operating system. It is completely featured but quite streamlined at the same time. The operating system running all Cisco routers include features that support the most complicated configurations, meaning the routers can be adapted to work in almost any situation. Uh, Nevertheless, the Cisco OS will be complex or difficult to use with such a strong command structure and given the complexity of router operations. But the Cisco iOS is incredibly user friendly and quick to understand. The Cisco is easily learned by someone acquainted with basic PC functions and terminology. I think that is it from me. Thank you, and I'll be passing the next part to my partner.
Assalamualaikum warahmatullahi wabarakatuh. Today I'll be explaining on how to operate our autonomous system project. Okay, so we created the autonomous system via Python on Linux. So we have connected the virtual box with the router. It is connected to the fast Ethernet port, fast Ethernet cable. And then we have to set the IP on the router. The router IP that is connected to the VirtualBox is 192.168.1.1. Subnet mask is /24. And we have to set the SSH so that the configuration can be done via remotely from the VirtualBox. Let me see. Here we have set up the SSH. The command for the SSH will be included in the documentation. So, and then for the IP from the VirtualBox, we have set 192.168.1.11, and it is connected to router 1. Okay, and then is to test the connection between both sides. So 192.168.1.1. You can see that we get the reply from the router, and from here the thing is successful, meaning the connection can be established in both sides. So on to the program that we have created. So we are using Python 3. Let me just briefly. Okay, so we will run the program. Okay, as you can see, our program can do two things, which is setting the interface and set the BGP. So I will show you on how interface can be done. So I'll choose the interface and how many interfaces. It depends on how many you want. Example, we created three. So we have to create 3 interfaces, but as for this explanation, I will only just show one. On interface /0, IP address I will be putting. This is just an example. As you can see, we have created the interface on router 1. You can see on show interface brief. Show IP interface brief. You can see that serial 1/0 has been configured via VirtualBox. And next is to set the BGP. This is, by the way, this is just an example. BGP. Example, let's say router AS number is 100, and number of neighbor, let's say I only have 2. Number of network is 2. Let's just create this. Let's say the other router is 100. You can see that the BGP has been made. And then second neighbor. Let's say if it's a eBGP, we entered a different AS number. Okay, as for the network, we just simply put 168.1.0 followed by the mask. Just to remind you that this is just an example. The full tutorial on our project will be done after this explanation. So, okay, we have successfully created the BGP. Alright. From here, we can see that the BGP has been made via virtual box. Okay, that will be all for the explanation on how our project works. And now for the full tutorial of the setting of BGP from this diagram.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to my lecturer, which is Encik Kamarul Arifin bin Abdul Basit, and to my fellow classmates. My name is Aminuddin Afiq bin Tamin, and I will proceed with the result and analysis for our team's program. In this section, I will show the result, which is the BGP table of the router. For the first router, which is R1, as we can see here, the BGP table. Before that, I will explain that BGP. There is two type of BGP, which is IBGP, which is the internal BGP, and next which is eBGP, which is external BGP. I will identify which of the type for each network in the routers. Okay, for the first network in R1, which is 172.15.10.0, and its next hop, which is 172.15.10.13 and 172.15.10.21. Its next network, which is 172.16.10.0, and the next hop, which is the same, 172.15.10.13 and 172.15.10.21. Okay, here for the next hop, the addresses 172.15.10.13 is the address for router 3, and the address of 172.15.10.21 is the address for router 2. Okay, next, which is 192.168.1, which is the loopback address for router 1. Okay, and then the 192.68.2.0 and its next hop, which is 172.15.10.21. These addresses is the addresses for router 2. Okay, for router 1 and router 2, we classified it as IBGP, which is internal BGP, because it is under the same autonomous system, which is AS. That is why we classified it as IBGP internal, which is the same in the same as. Okay, then the last address network, which is 192.16x.3.0, and its address, which is 172.16.10.3. Okay, this addresses is also the 172.15.10.13. Okay, this addresses is belongs to router 3. Okay, for R1 and R3, we classified it as external BGP because R1 and R3 belongs to different not external BGP, because R1 and R3 belong to different autonomous system or AS. Okay, we will proceed with the next. Before that, as we can see here, we can see that in this table, it will prefer the root of 172.16.10.3 because it has higher local preference for R3. Okay, the same for the 172.15.10.21 because it has higher local preference. Okay, next, which is router 2. As we can see here, router 2, it has the same network as router 1, 172.15.10.0 and 172.16.10.0, and its loopback, which is 172.168.1.0, and the next hop, which is 172.15.10.0. These addresses belong to router 1, and 192.168.2.0. This address belong to R2, and lastly, which is 192.168.3, and its next hop, which is 172.15.10.13, and the other one is 172.16.10.3. Okay, this address belong to router 3. The same with router 1. Router 1 and router 2 is classified as IBGP because it is under the same AS. While for R2 to R3, it is classified as eBGP, external BGP. Okay, finally, which is router 3, as we can see here, the same with R2 and R3. It has a network of 172.15.10 and network of 172.16.10. And its next up is 172.15.10.11 and 172.16.10.2 for the first network, and the second network is the next hop, which is 172.15.10.11 and 172.16.10.2. Okay, and next, which is the network of 192.168.1.0 and its next hop, which is 172.15.10.11 and 172.16.10.2. These addresses, sorry for the error, but these addresses actually belong to R1, which is router 1. There is a problem at the slide. Okay, the R2 addresses is actually is 192.168.2.0 and is next hop, which is 172.15.10.11 and 172.16.10.2. That is the address for R1 actually. Sorry for the mistake. And finally, which is R3 network or loopback address, which is 192.168.3.0. Okay, this is for the result analysis, and I will proceed with the conclusion of our project. The conclusion is BGP plays critical role in internet routing, and there is a significant need for a tool to automate its tedious manual configuration and troubleshooting technique. Our team are able to create a program automation BGP configuration program using Python programming language. We have tested the program, and it is successfully, and we have evaluated the BGP automation in terms of its connectivity of routers in 2 different AS. Okay, that is all from my team. Thank you very much. Thank you, Encik Kamarul Arifin bin Abdul Basit, for your time, and and to my classmate also, and thank you for my teammate because the contribution and teamwork for this project. Thank you very much.